All right, this is Unit 7, Lesson 10.3, Timing a Blob of Water. So an engineer is designing a fountain that shoots out drops of water. The nozzle from which the water is launched is 3 meters above the ground. It shoots out a drop of water at a vertical velocity of 9 meters per second. Function h models the height in meters, h, of a drop of water t seconds after it is shot out from the nozzle. The function is defined by this equation. H of t is equal to negative 5t squared plus 9t plus 3. How many seconds until the drop of water hits the ground? How many seconds until it hits the ground? Well, I think we need to figure some things out. So if we think about this, it said it started at 3 meters off the ground. It shot up at a vertical velocity of 9 meters per second, and then eventually gravity will take over and bring it back to the ground. And we want to figure out how many seconds have passed once I get there, right? So where are we right there? That's what we're trying to figure out. And each of these questions will help us get there. Okay, the first one says, write an equation that we could solve to answer the question. So what am I trying to figure out? When this equation is equal to what value? When the height is equal to what? When we're on the ground, what is our height? Our height with respect to time. So yeah, the height is going to be 3 here, 2, 1, 0. When the height is 0, we are on the ground. You probably already said that. Write an equation that we could solve. We want to know when negative 5t squared plus 9t plus 3 is equal to 0. Great. All right. So then it says, number 2, try to solve the equation by writing the expression in factored form and using the zero product property. So we need to try to factor that. Negative 5t squared plus 9t plus 3. So let's see. We tried factoring. Okay. So we are going to try to solve this equation by writing it in factored form. So we know that this, I see, we have a negative 5t squared. So what I'd like to do is move everything to the other side or multiply through by a negative 1 so I don't have to deal with this negative. So I'm going to multiply both sides by negative 1. So if I multiply this side by negative 1, I still get 0. If I multiply this side times negative 1, everything gets multiplied by negative 1. So here it turns into a positive 5t squared minus 9t minus 3. All right, this will be a little easier to try to factor. All right, so I like 5 and I like 3 because really there's only one way to multiply with integers and get 5. It's 5t times t. 5t squared. There we go. Okay, and this would have to be negative 3, and these two together would have to give negative 9t. So what times what is 3? Well, there's only two ways. Again, it's either 1 times 3 or 1 times 3. So either the 1 is up here or the 1 is down here. So if I do this, 5 times 3 is 15t, and 1 times t is 1t. Can I get a negative 9 with those? Not really. Now I understand that one of them has to be negative to get a product of negative 3. But 1 and 3 in that order are not going to work. So let's try, maybe it's 3 and 1. All right, so if I put a 3 here and a 1 there, 1 times 5 is 5t, and 3 times t is 3t. Well, 5 plus 3 isn't negative 9 either. Well, that's really frustrating. And in this problem, we're hoping that you get frustrated. Is there any other way that we could address this? Okay, so not every problem is factorable. My goal was to write it in this form so I could use zero product property like all the other problems, but there are no integer values that I can find that will get me negative 9t as my middle term. Okay, so we're going to need to have some other strategies as well, because sometimes they're not factorable. All right, so problem 3 is asking us to try to solve by graphing the function using graphing technology. So I'm going to show you Desmos. So let's go to Desmos. So I've already plugged it in. So now we have our graph. We want to find the solutions to this equation. When is that equation going to equal 0? Well, these two spots right here on the graph are where it equals 0. This doesn't make much sense, like we said, because it's negative time, but this one makes more sense. So at t equals 2.087 seconds, the water's going to drop and hit the ground. So it's about 2 seconds.